So in this video, we will see where exactly these sensors are working and what is the total picture comprising of all layers and protocols. This will be a quick introduction and we'll learn more about the protocols. So we have already seen this OSI application, OSI model for networking. So we are going to map this IoT communication also onto the same OSI layers, because IoT communication takes place over IP. So if your sensor cannot talk in terms of IP, your data will not reach the internet. So we must have a clear idea about where exactly our devices are, where exactly our gateway, what are the different protocols operates to have a seamless communication. So this shows the different layers we have seen and the devices that can happen operate at the different layers. So an IoT gateway can operate at any layer. So end devices, mostly they will cover up to network layer. They can communicate over IP protocol. After that, the processes will be running on end hosts and so on. So there are a lot of protocols operating at different layers. We have learned all of them, but what are the protocols specific to IoT at each of the layer? That's the topic for today's discussion. So side by side we have this 4-layer model by Department of Defense ARPANET. So they map it into 4 sections: processes, host-to-host communication, intranet, and network. So whatever model you use, you must have some means of pushing the data to an IP network. If that is there, your device is internet ready and it can be a part of Internet of Things. Okay, so let us look at the protocols available at different layers and see how to use them. Okay, so let's start from the bottom, from link layer. Physical layer, there are voltages and signals. There you have, in physical layer, you have this SPI, I2C protocols, analog to digital conversion. All signal manipulations at the analog and digital will be happening in the physical layer. From that physical layer will make what is known as frames of data, which will be given to the link layer. So what are the link layer technologies specific to IoT? So for each protocol, there is a standard number by IEEE, because IEEE has standardized these protocols with their 802.x series. They are all meant for IEEE 802 standard release. So in that, some LAN protocols, 802.x protocols, which are at link layer. So let us have a quick review of them. This protocol you have already seen. We have been talking about Ethernet. Okay, that is the actual number. 802.3 is Ethernet. Ethernet comes in different data rates: 140, 1 Gbps, up to 1 Gbps it is there. It can operate over coaxial and also twisted pair. What we use in our labs are twisted pair cable. Okay, you might hope you have seen the internal. It's actually a 4-pair twisted unshielded UTP twisted pair cable. So 802.11 is the usual Wi-Fi. So as engineering graduates, we must use the actual term. So Wi-Fi is somewhat a term used by non-technical people. So when we say, we should say what kind of Wi-Fi it is. 802.11b, G, different standards are there based on their media access protocols and their connectivity. So as an exercise, you have to list the Wi-Fi protocols supported on your laptop. 802, whether it is 802.11b or G, what is the difference between B and G, etc. We will have a discussion on all these points after the video is over. Okay, so if you want to use cellular communication, you can go ahead with the usual GPRS, which is 2G or higher versions. Now, I heard that 5G is also deployed in some places. Then another one is a failed technology actually. It came from BSNL 802.16, which is WiMAX, which is no more used as far as I know. Maybe Dr. Anandaran sir may be able to give more light on this WiMAX. It was launched by BSNL as an infrastructure so that you can use the 802.15.1 is Bluetooth. So Bluetooth is having again different versions with Bluetooth version 4 low energy and so on. So as an exercise, you have to find out the latest IEEE 802 number for the Bluetooth communication. So what kind of, as an activity, you can find out what is the Bluetooth connectivity supported on your mobile phone. Okay, you can find out and tell us after this hour. So next comes low power wireless personal area network, which is used for transmitting very small amount of data over large range, that is wireless personal area network. So you have 6 LOPWAN is there, which is focusing on IPv6. So get more details on this and check whether there is any possibility to use such protocols in your use case implementation. So needless to say, whenever we talk about any technology or any point as part of the theory discussion, those are meant to be used in some way or the other in your use case. It's not something you need to study and use to answer the assessment. So think whether you can use any of the points that comes from our discussion in your use case implementation. That is how you have to look at the lectures. So that's about link layer technology. So hope you remember the activities which I gave you as part of this. Next, let us go to the network layer, the layer next above the link layer, which is network layer. Network layer is meant for host to host communication. So we need a host level identification. It can be used with IPv4. Now IPv4 is completely is on the verge of exhausted. So we have to use IPv6, which comes with 128-bit addresses, which is sufficient to assign to any any grain of sand on the network on the world. Okay, next you have IPv6 based low power personal area, wireless personal area network can be used. Then you have protocol ICMP v6, which runs on top of IPv6. We have the normal ICMP which runs on IPv4. Then you have RPL routing protocol for lossless links. That is another thing which used in connection with IPv6, RPL. So these are targeted for constrained devices. So this is a term which we encounter mostly in IoT, constrained device. So what are the constraints? So constraint could be in terms of processing power. You may not have a powerful processor in an IoT sensor. The processor could be an 8-bit controller like Arduino or some low power devices like that. The memory available will be less, few KBs, and your power supply will be from battery, so that also is limited. So these protocols should be able to work on a constrained device. That is the beauty of all these IoT protocols. They are specifically designed for constrained environment. Now moving further, in transport layer we have good old TCP and UDP, because it's not that easy to change something in transport layer because of the way it is designed. Okay, so they deliver end-to-end datagram transfer independent of the underlying identification, whether you use IPv6 or v4 or RPL. The payload part is going to be either UDP or TCP TCP segment. Now coming to the application, here we have a lot of modifications or new protocols. So the traditional HTTP is not suited for a constrained setup because HTTP is a kind of heavy protocol. A heavy protocol means it doesn't mean that a program is weighing more. It means that a heavy protocol will have a comparatively larger header and trailer, or sometimes you'll have only header. So lighter protocols header will be very short. So the communication overhead for HTTP is very high as it is a heavy protocol. So we won't go for HTTP when you want to write something in the application layer of IoT. Instead, we prefer COAP or some other techniques such as XMPP, MQTT, distributed and distribution service, AMQP, and so on. There are a lot of such protocols used in the industrial IoT. We will give you some latest protocols once you learn all these things. Okay, so that's about application layer protocols. So next topic would be with this IoT specific protocol, in what way you are going to communicate. Is it going to be a request response or like kind of client server model, or are you going for some other kind of paradigm for communication? That is the next topic. So let us see that the communication models available for the Internet of Things. Okay, so let's start from the very familiar client server model. So you have sensors, actuators, data, retrieve data, and you have a client who sends and gets the response from the sender server, and the server is talking to the sensors, gets the data, and it also directs the actuators. It does some analytics by storing and retrieving data. So this is the traditional request response based communication system which you might have implemented in your network lab: client requests and the server response. Another thing is, see, this request response has got a lot of issues such as connection establishment, maintaining the details of connections, managing concurrent connection. A lot of issues are there which are inherent in request response. So this one is free from most of such things. This is a kind of publish subscribe. So there are two entities. One act as a publisher and another act as a subscriber. So whatever information you are interested, you make a subscription. So whenever that information is ready, you will get it. So our MQTT protocol is working based on this philosophy. So there is a publisher and a consumer. This consumer will be subscribing to the service, and there is a broker who sits in between, and they are mapping the consumer's subscription to the publisher. So there will be multiple consumers with different topics. So brokers will aggregate the subscriptions based on the topics and contact the publisher and make the communication possible. That is the role of broker. So this is actually an overview. We will see more about them in the topics coming, where we learn more about the application layer and we will see example programs using MQTT. Another thing is push and pull method, where the consumer, whenever he wants, he will pull the data. So he knows from which channel to contact and so on. So like this push-pull, exclusive pair, REST-based communication, lot of things are there. So now it's too early to talk to you about such things because we want to implement at least one basic client server. Only then talking about the advanced thing will make sense to you. So let us conclude here with this. So you'll have the assessment in the coming classes from all the lectures that we had so far. Thank you.